Hey everybody, today we will do another video, and today we will continue with undetermined coefficients. Undetermined coefficients. Okay. And of course, this is differential equations. Okay, okay, so technically solving, can say solving differential equation using this method, undetermined coefficients. Okay, so basically what we will do a problem again. And the problem is following. Problem is number 4 in the same book that I always, one of the books that I use, but not necessarily it's just, this one. So it is number 4 in exercise 4.4 in this book. Okay, so let's get it started, right? So the problem says y double prime plus y prime plus y prime minus 6y equal to 2x. Okay, so step number 1, what we do? This is a non-homogeneous differential equation because it is a non-homogeneous differential equation. We need to make it homogeneous first, and then trying to find the root of the system of this equation to find a complementary solution. Once we find a complementary solution by making the left side homogeneous, then we will continue to find a particular solution by finding the undetermined coefficients, right? So the first step is what? Is making this guy 0, making this equal to 0, right? So first step, we got a y prime, y double prime plus y prime minus 6y equals 0, right? Now, what we do right here, we replace this by some certain values of r, right? To find the roots. I mean, some books use d, but I like to use r because that's to find the root, right? So where is a second derivative, we put r to the second power plus r, in this case, plus r to the 1 power. I don't have to write it 1, right? I know that r to the 1 power just look like this, minus a constant, right? So now this y, this is becoming like, the form of y equal to ax plus bx plus c, right? In this case, I got my a, my b, my c, right? Now this is my c, which is a constant, which is 6, right? It's equal to 0. Now let's try to see what we can do with this to find the root. We know that when we find the root, we make this equation equal to 0, right? In basic algebra. Now what we're doing right here is basically finding the root of this equation, right? Now, how do I do that? Well, I can use the quadratic formula. I can try factoring first, and I will try factoring. So in this is called an auxiliary equation, right? So what I can do now is factor, right? Factor r. I know I got a 2r because I got an r squared. In my smiley face, I need to put r, right? Now think about this. One number, you add r to get a positive r, right? When you have this. Well, in order to make it, and then I have a 6, right? What number does multiply 6 to give me a positive r, right? And in this, I have 2, 2 times 3, right? 2 times 3 and 3 times 2, right? They both work to give me 6. However, one of them has to be a negative in order to get this negative, right? So now what I can do is, but if I add the two middle pieces, right? What do I have to do? Well, I have to distribute first in my smiley face and then add the two terms in the middle. In this case, I got a positive r, so I might want to try 3 first, right? And then r over here and minus 2. Let's see what I get. R times r is r squared. R times negative 2 is negative 2r, right? Then then r 3 times r is positive r. Well, when I add those two, I get this. So this is the right thing. This is the right factoring. So now I set up equals 0, right? Now I do r plus 3 equals 0. So therefore, negative 3, add, subtract 3 on both sides, and I get r is equal to negative 3, right? The first root. Second root, I got r minus 2 equals 0, plus 2 on both sides, and r is equal to 2, okay? So now, what is my what is my complementary solution? My complementary solution in this case, my complementary solution in this case is equal to what? It's equal to yc complementary, right? Which is going to be equal to what? It's going to be equal to c1. Now, notice that I have a I have a distant root, which I don't have to put a next in between my second c and between c2 and e, right? An exponential e. So I have a distant root, which I have to do basically, in this case, right? So e to the second power, right? This e to the second power. Normally we put this the positive in the first c, and the first e, right? In this case, c1, right? So now I got plus c2, right? Plus c2 e, and I got negative 3, right? And it's x, right? That is my complementary solution. Now now I'm going to do the process for the left side, right? So now let's assume that y is equal to some certain um ax something, right? So let's say that a plus ax, why ax? Because I know I have an a, but I also have a variable right there, but I have a 2 in front of that, right? In front of the variable, I have a 2. So that can be ax plus b, right? Now, I'm assuming that this y is equal to something in this right side because I have it this, right? Now, let's take the derivative of this. How many derivatives do I have? I have a second derivative and I have a first derivative, right? So my first derivative is the following. So y prime, right? Take the derivative of that is simply with respect to x, that is a, that becomes 0, right? First derivative, I am taking the with respect to a, right? I have the first derivative is equal to this. So my second derivative of a, right? Taking the second derivative, and my second derivative is going to be nothing but 0, right? So I have my first derivative and my second derivative, right? Now, what do I do, right? Well, I need to, let me just write it here. Y prime is equal to a, y double prime is equal to 0, right? I need those. Okay, so okay. So basically, and my solution was y equals c1 e to the 2x plus c2 plus c2 e to the minus 3x, right? That is my complementary solution. Now, now let me find the rest, right? So now I have my my double derivative, which is basically second derivative, and I have my single derivative, which is this one. So what I do, I put 0 for this first derivative, I put 0, right? For the second derivative, put 0, right? And for the first derivative, I put a. So I substitute that with a, and then of course I have a 6 right here, right? There's a minus 6, right? And then we said that y y y y equal ax plus b, right? Now what I'm gonna do is the following. So what I'm gonna do is substitute ax plus b inside is equal to 2x plus 0. I need to make it sure that I compensate for any lower power that I have after that, after this power, any lower power or constant that I have in front or after this first term. Now, what I can do is simply distribute that 6 inside, right? And I get a minus minus 6ax, right? Ax minus 6b equal to 2x plus 2x plus 0, right? Okay. So now what do I have? As you can see right here that you have some similar terms, right? So what I can do is set this equal to that, right? And I say that negative 6ax is equal to 2, right? 2x, right? Now what I can say is that this is gone, and I can say that 6a 6a negative 6a is equal to 2, right? Divided by 6 on both sides, and of course that is negative, and I get that, and I get that, and I get that a is equal to negative 1/3, okay? Negative 1/3. Now, there's my a. Now I need to find my b, right? So now a equals negative 1/3. Okay. And keep in mind that we have to remember that we had an x involved in the a term, right? Keep that in mind. Now, what is the so so in this case, right? So when I do that, well, I think I erase it, but okay, so let me do it again. A minus 6ax minus 6ax minus 6b equal to is equal to 2x plus 0x. Okay, so we got this already, right? We got that, and it's gone. Now what I have right here is a, right? I have this a, and I have this 6b. 6b is equal to what? To 0. That's 0 right there, right? 0, right? This 0. Now, now, if I look at this, I already have the value for a. So all I gotta do in this case is the following. So all I gotta do in this case is the following. So I gotta do -3, okay, -3, and then negative b is equal to 0, right? Now what I can do is basically add this on both sides, right? So when I add that, I get add 1/3, add 1/3, right? Add 1/3 on the other side, and I get negative 6b is equal to positive 1/3 on the other side. Right. Now, what I'm going to do is divide by 6, right? Divide by 6, divide by 6. In order, when I divide by 6 this, okay, so this becomes what? Divided by -6 in one shot, right? Why not? So b is equal to what? It's equal to 1/3, right? And then when I divide by that, I flip it. So this is over 1, right? That 6 is over 1. So when I flip that, that becomes multiplication, right? When that becomes multiplication, that will become a 1/6 like that, right? 1/6, you can say, and which is equal to negative 118. Okay, so negative 118. Now, what will be, okay, so I got it the B, I got it my A, right? What will be the final answer? My final answer is going to be the following. My final answer is going to be the following. It's going to be, it's going to be my complementary solution, which is this, plus my particular solution, which is going to be what I found by the undetermined coefficients, right? And and then I have to see that I have to look at a term where my A, when I found my A, I had an X in there, so I had to compensate for that. So I had to, so my general solution, Y general, is going to be equal to my complementary solution um, plus the particular solution, right? So like last time we say that Y general is equal to YC plus YB, right? That is the Y general is equal to Y complementary plus Y particular, right? So now in this case, I have C1e to the x to the 2x plus C2e to the negative 3x, right? Plus a, right? Plus minus 1/3. You can say, you can put it x You can do it like this. You can put one third x, right? And then minus what? Minus a constant, which why? Why the constant? Because when I found a term, it got a nothing in front of the coefficient. You just had a zero, but it was a constant, right? So therefore, this is negative 1/8, 1/18th, right? So now 1/18th. Now, what you can do is just simply do it like this. It's the same thing. So here you go. So that is the solution for that differential equation. I hope you enjoyed this video. If you do, please give me a like, and I see you in the next video. Thank you for watching.